Okay, in this video, we're going to look at uh, some examples of solving right triangles, solving for sides of right triangles using Pythagorean theorem, where we'll need to reduce radicals as well. So as a reminder, the Pythagorean theorem, when we're dealing with a right triangle with legs A and B and hypotenuse C, we know that A squared plus B squared equals C squared. And in reducing radicals, we're going to be working with some situations where if I had the square root of 12, I know that that is 2 root 3 because 12 breaks down into 4 times 3. 3 is prime. And 4 breaks down into 2 times 2. There's a pair of 2's, so it comes out. The 3 stays in. So let's get through a couple examples. Here's our first one. Find the value of x in the triangle below. So I notice that my right angle is here, and across from this is 9. It's a little bit tricky to see in this very tall triangle, but 1 and x are adjacent to the right angle. 9 is opposite, so that means we're dealing with a squared plus b squared equals c squared. The 9 will be my c, so I'll have a 9 squared over here. The 1 and the x can go in any order, so I'll have 1 squared plus x squared. These numbers are small enough, I won't really need to go to the calculator, so 1 squared is 1. I have x squared here, 9 squared is 81. I'm going to subtract 1 from both sides, so 81 minus 1 gives me 80, so I have x squared equals 80. And then to get rid of the squared, I take the square root, and I always will go and check to see if this is a nice square root. It's pretty obvious in this case, but sometimes it's not obvious. And when I press the square root, I get a decimal, which means I get my approximate 8.944. So x is approximately 8.944. But if I want to get the exact answer, I can break down the square root. So I'll take my 80 and I'll see what goes into it. Now, I know that 80 is 8 times 10. 8 is 4 times 2. 2 is prime. 10 is 5 times 2. 5 and 2 are both prime. And then 4 breaks down into 2 and 2. And I look for pairs, so I have one pair of 2's, a second pair of 2's, so 2 times 2 on the outside, and a 5 left over on the inside. So the exact answer is x equals 4 root 5. All right, next problem. Find the value of x in the triangle below. So same start, right angle, go across to find c. c is x in this case, so I have an x squared by itself. I have on the left-hand side, a squared plus b squared, so 6 squared plus 8 squared. 6 squared is 36. 8 squared is 64. I just add 36 and 64 to get 100. And to get rid of the squared, I take the square root. Now, always check to see if that's a perfect square. So the square root of 100 is 10, which means x equals 10 is my answer, and I don't need to break it down to get the exact answer. All right, another problem. Find the value of x in the triangle below. So I start off, here's my right angle. Across from that is 12. So that means 12 is my c, 12 is my hypotenuse. So I have 12 squared. On the other side, left-hand side, I have x squared plus 6 squared. And I'll work this out. So bring down the x squared. 6 squared is 36. 12 squared is 144. I'm going to try to solve for x by first subtracting the 36 from both sides. And I'll go to the calculator. Don't really need it, but I'll go to the calculator. So 144 minus 36 is 108. So I'll get x squared equals 108. And then to cancel out the squared, I take the square root of both sides and always check first to see if it was a perfect square. So I press the square root and it's a decimal. So I get my approximate answer, 10.392. So x is approximately 10.392. If I want to get the exact answer, I'm going to break down the 108. Now, in here, if you don't see anything, so there are lots of choices, but if you're stuck on finding a factor, see that this is even, so you know 2 has to go into it, so I can just start off with 108 divided by 2, and I will get 54. And let's just say that you're still not seeing any good answers, good choices, but 54 is still even. So I can take another 2 out, and I can go and see, when I divide by 2 again, I get 27. And now we're into some nice numbers. 27 is not even, but I know that 3 goes into it, so that's going to be 3 times 9. And 9 breaks down to 3 times 3. And I notice that I have a pair of 2's, a pair of 3's, but 1 3 left over at the end, so my exact answer is 6 root 3. Okay, moving on. Same start, find x in the triangle below. So first I'm going to identify c. In this case, 6 is c because it's across from the right angle. So I'll have x squared plus 5 squared equals 6 squared. 5 squared is 25. 6 squared is 36. And these are definitely small enough I can do this without a calculator. So 36 minus 25 gives me 11. I'll do the same process. So square root, check the calculator to see if 11 has a perfect square root or a nice square root, and it does not. So I'm going to round my answer. Notice, since the 4th decimal place is 5 or bigger, I will round this up to 3.317. So x is approximately 3.317. And if I wanted to get the exact answer, I will break down the 11. But 11 doesn't break down. 11 is prime itself, and there's no pair of numbers to break down, so my exact answer is actually just going to be the square root of 11. Next problem. So find the value of x in the triangle below. First, identify c. So right angle across the right angle is 7. So 7 is c. So 7 squared goes by itself. On the left-hand side, we'll have x squared plus 3 squared, and we'll work this out. So I have x squared plus 3 squared is 9. 7 squared is 49. I will subtract 9 from both sides. And that leaves me with x squared equals 40. I'll take the square root of both sides to get rid of the square. And as always, I'll check the calculator first, hoping that 40 has an integer square root. It doesn't. I will round this up as well because the 4th decimal point or 4th digit after the decimal is 5 or bigger. So I will round this to 6.325. 6.325. And now, if I wanted to get the exact answer, I will break down the 40. So 40 is 4 times 10. 4 breaks down further as 2 times 2. 10 breaks down to 5 times 2. I looked for pairs. There's a pair of 2's, so I'll bring out a 2. I don't see any other pairs. I see a 5, I see a 10, so I'll leave a 5, sorry, a 5 and a 2. So I have 5 times 2 inside the square root, and when I combine what I can, I'll get x is exactly equal to 2 root 10. And our last example, same setup, solve for x in the triangle below, find the right angle, go across from that right angle, and that tells me that c is going to be x, so I'll have an equals x squared on the right-hand side. On the left-hand side, I'll have 5 squared plus 10 squared, the a and the b, and then 5 squared is 25, 10 squared is 100, 25 plus 100 is 125. I'll take the square root of both sides, and as always, go to the calculator, hope that 125 is a perfect square, and it's not, so I'll have 11.180 is my approximate answer. Okay, now to go after my exact answer, I'll break down the 125, and a lot of the problems I've seen so far have been even, but if I look at this, when I try to do 125 divided by 2, doesn't work. Gives me a decimal. If I try 125 divided by 3, doesn't work. But we should know, since 125 ends in a 5, it has to be a multiple of 5. You know, when you 5 count 5, 10, 15, 20. Everything that's a multiple of 5 ends in either 5 or 0. So 125 divided by 5 gives me 25. So this is 5 times 25. 5 is prime. The 25 breaks down to 5 and 5. Those are both prime. I look for a pair. I see a pair of 5s, so a 5 comes out. I have a 5 left over. That's left in. And so my exact answer is x is equal to 5 root 5. Hopefully this helps clear any questions up. There will be a link to the worksheet down in the description below.